Hey, so we're up to part 3 of the grade 5 Show Your Work Hardest Math Problems. So I'm going to jump right into this today without all the banter. Okay, our first problem is Harry's fitness trainer recommends that Harry drinks 8 fluid ounces of water 8 times a day. So we're up to there. So this must mean 8 times 8 equals 64. So again, you guys need to know your multiplication table. Harry has a bottle of water that holds 1 1/4 pints when filled. Today he filled the water bottle 3 times. Okay, so we have a water bottle that has a capacity of 1 1/4. Okay, and he fills it 3 times. If you notice, they do something here. They're mixing numbers with words. Okay, they didn't use the digit 3 there. Sometimes that can fly past kids, and they're going to think that Harry only used 1 1/4 pint. However, he did it 3 times. So you all should know that that's 3 3/4 altogether. So this is pints because this originally was pints here, right? Okay, this is fluid ounces. Okay, because they told us that over here. Okay, so we probably had a unit conversion issue that we're going to have to be concerned about. Harry claims that he drank the total amount of water recommended by his fitness trainer. Explain why Harry's claim is true or not. Okay? So what we need to do is map either pints to fluid ounces or fluid ounces into pints. So we definitely need to do a unit conversion to figure that out. Okay? You guys are provided a table. Give me 1 second. Let me see if I can get that loaded up in here. First of all, you guys should memorize these things. However, often what you're using will provide you with a reference sheet. So that's what I'm loading right now. And it's too tiny, so let's see, can we do that? All right, so what we're needing to do is we were given fluid ounces. We were also given pints. So we're going to have to do that mapping back and forth. All right? So if 1 cup is 8 fluid ounces, then 2 cups is how many, right? So you should be able to see that that's 16. So 2 cups is 16. The reason I'm moving this to 2 cups is because 2 cups is 1 pint. So it turns out that 1 pint is equal to 16 fluid ounces. Okay, so we can also write that as a ratio. 1 pint is to 16 fluid ounces. Okay, so what we're going to do is we're going to go back to the other thing. 1 pint is 16 fluid ounces. So we had that 1 pint is to 16 fluid ounces. Okay, we also know he actually used 64. So if we set up that ratio with 2 ratios, as in we don't know how many pints he used, to 64, because that's how much he's supposed to be drinking. Okay, therefore we can find it out. We can use the cross product, a couple of techniques here. Let's just use it. So 1 times 64 equals 16 times x. Divide both sides by 16. And we get 4 equals x. This is in pints. 4 pints. So that means Harry's fitness trainer. So we went in the reference table calculated that. It didn't give us directly, but we figured it out because 1 cup is 8, right? And 2 cups is 16, and 2 cups is also a pint. So we can do that proportion and get that figured out. So his trainer is recommending 4 pints. Okay, we just showed that he used 3 3/4. So is Harry's claim true? No. Okay, and it's not flipped. Don't think he drank 4 pints and the trainer told him 3 3/4. That's not what this problem says. All right. You are not also taking 4 plus 3 3/4. That is not what that's asking about at all. The trainer's recommending 4 pints, and he drank 3 3/4. That's the end of the problem. All right. So this is testing your use of doing a word problem. It's testing your use of fractions. It's testing your use of mixed fractions. It's testing your use of conversions. And in this case, you should know these conversions, but it actually gives it to you in a reference sheet, at least from the exam I'm using here. You don't have to be doing these problems from exams, but that is what it did. All right. So key was getting this table here. Let me just change the color of that. Let me use was getting this conversion right there. That was our cornerstone / keystone thing to convert the pints from the fluid ounces, based off of cups even. All right, because we started from 8 fluid ounces over here. All right, so there's things like that. Okay, so you can see now if you follow this on grade 3, grade 4, really focus on multiplication. And there was multiplication involved here, but this is really dealing with unit conversions of fractions. Okay, that's really the biggie here, and it's getting what will be the unit conversion that you need to do. That's really super key. I know we're repeating this, but this is an aspect of grade 5, at least in New York State, and seems through the country as well. So this is kind of something that you guys need to work on and figure out too. This, and just to double check, if we come down here, if you notice, it's not looking for anything. It doesn't say answer. Why? The reason why is it never asks us to actually compute the 64 or the 3 3/4. It says explain why. So it wants an English description explaining why. But there's no way to explain why unless you did those computations. All right? So this actually doesn't say show your work, but it needs you to explain it. So within the process of you doing the explanation, writing the words out here, you're going to be actually showing you a solution to that. There's slight variations to this. In other words, you could have said this was 3.75, okay, instead of 3 3/4. That's not a problem. Let's see, what other things could go on here? Yeah, and again, I said this is not 4 plus. This is also not 4 times 3 3/4. Okay, don't go there either. Right? Take it a sentence at a time. See these little things I put here, these little slashes? I'm doing that for myself, although I'm trying to be a role model, but you guys should be processing the sentences one at a time, making sense out of it, and only then going to the next sentence, making sense out of that, and then making sense out of the first 2 sentences. Once I get to sentence number 1 and figure that, and then sentence number 2 and figure that out. Over here, I'm processing 1 and 2, not just 2. Okay, and I'm making super thoughts of everything combined as I iterate along, so that I'm understanding each part. And as I get to each little bar I drew here, like this bar here, okay, I'm asking myself questions. These are not 10-hour questions. They're 5-second questions. And if the answer is not there, that might be what they eventually ask me. And if the answer is not there, I hope it's in the next sentence. And if the answer is not there, maybe that's something I have to compute as a temporary value to finally get the answer. Okay? All right, so this is a 2-part problem. The first part was to figure out the 64 ounces. The second part was to figure out this, and then compare the two of those. So it turns out there was a step 3 as a consequential damage to having to do that, because at this point we have to do a unit conversion. Okay. We also had to convert the pints back into fluid ounces. Okay, that's another thing, right? If a pint is 16, then what we would have got was 1 pint is the 16 equals, and now we know this is 3 3/4 is to x, right? So then what we're to solve this, we can do the cross product. So we get x equals 16 times 3 3/4. Okay, we can map this into a top-heavy fraction. That's 12. That's 15/4. Okay, times 16. I can take my 4 and divide it into here 4 times. So I avoid 16 times 15, and now I have 15 times 4, and that's equal to 60. Okay? So it turns out he drank 60 ounces, and he needs to drink 64. So he's off by 4. If you notice, that's the same 4 we got earlier. Right? 64 minus 64 is what he's supposed to be doing. He drinks 60 by using this alternate solution I did right here. So we can go both directions, and this is a way to double check your answer sometimes as well. All right, so that's a cool question, and it's bringing us to different places and areas. Okay, Rodney bought a 25-pound of dog food, and before I do that, let me just make sure this seems to be going right. Okay, cool. Rodney bought a 25-pound bag of dog food. His dog ate 2 2/5 of dog food. By the way, give me 1 second. I want to have my phone go off. I'm testing the battery of my laptop right now. Okay. His dog ate, so we have up to here. There's not a lot of deets there, but we know there's 25 pounds. His dog ate 2 2/5 a pound in the first month, and 4 4 in the second month. Okay, how much dog food in pounds was remaining? So there's a couple of ways to do this as well. We can do 25 minus 10 2/5. Okay, whatever that is equal to, let's say it's x, and let's subtract from that 10 4/5. Okay, and then finally get the answer here. I'll use double x, that would be the answer. Okay, the other thing we can do is add the two of these, so we can have 10 4/5 plus 10 2/5. So that means the dog ate 20 6/5. And that's, this part here is top heavy. So this maps into 20, and then the other is 1 1/5. So if we add those, we get 21 1/5, right? So that's how much the dog ate. Okay, if we use the alternate way to do this, I'll actually do this computations over here. So we have 25 minus 10 2/5. This is basically 0/5, right? So to do that, we have to borrow a unit. So we make this 4. So this becomes 5/5, right? 1 is 5 over 5. So we're going to borrow 1 and use the same denominator. So 5/5 minus 2/5 is 3/5. And then we just do the normal subtraction over here. So we get 14 3/5. And by the way, guys, it's important to double check your calculations as you go on. So I can reverse this and get 24 5/5, and that's 25, so I know that. So I'm going to subtract from that 10 4/5 now. I have the same problem, which is that I can't take 3 4/5 from 3/5. So I'm going to take 1 here, which is 5/5. Add that to here, right? So basically I'm adding 5/5 here. So this becomes 8/5, right? So now I have 8/5 minus the 4/5 here, which gives me 4/5. Okay, and then I have 3 4/5. So if you notice, my two answers are different. Okay, this is what the dog ate here, and this is what the dog ate here. So this is what's left in bag. This was what the dog ate. So what we have to do is take 25 and minus 21 1/5 from it. You're going to go through the same process. We need to borrow 1, which is 5/5. Now 5/5 minus 1/5 is 4/5, and 4 minus 1 is 3. You notice we get the same answer here. All right? So again, this was a word problem. It was about splitting up into little pieces. It was about top-heavy fractions. It was more about operations this time. The other time it was about multiplication. Now it's just about basic addition and subtraction of mixed numbers. Right? A mixed number is a whole number plus a fraction. It was also about the borrowing. We had to borrow. Right? It's important to know how to do that borrow, to take one unit and bring it over there. Because in all cases, the top number right there and right here and right here, right over here, we had to carry a unit. So once you bring that unit over, you want it to be the same denominator as the bottom number's fraction. In this case, it was a 5 there. In this case, it was a 5 here. In this case, it was a 5 here. So any number over itself is 1. So it's easy just to grade 5/5 out of that. All right. So again, this is about operations of fractions. We could have done this using decimals. Okay, again, let me change the color of that so we get some kind of clarity of that. Okay, because we have two numbers, 10 and 2/5, and we have 10 and 4/5. So if we map this to tenths, we get 10. How many tenths is that? That's 4 tenths. Okay, and this is equal to 10. And if we do a denominator there, 4/5 is how many tenths? That's 8 tenths. Okay? So if we want, we can have 10.4. And this is 10.8. Okay, let me just make sure that I did that correctly. I have slight dyslexia, and I often copy numbers wrong. And especially a calculation like I just here is very error prone to me, even though it's simple. So let me just make sure. 2/5, 4, 10 and 4/5. So I get tenths out of that. That's a 0. Times 2, that's good. Times 2 there, 8. Right, so now that I got that, all I have to do is add them. 8 plus 4 is 12. 2, carry the 1, right? So I get 1 plus 0 plus 0. Drop down my decimal point. That's 1. And then I drop that down there. So this 21.2, it should be the same as that. And we know that 1/5, if it was a tenth, would be 2. So that's good. We get 21.2. So what we could have done at that point was 25 minus 21.2. This is 25.0. Okay? So we're going to borrow the 10. That becomes a 4. That becomes a 1. That's 8. Right? And 4 minus 1 is 3. We get 3.8. Is that the same as this 3 4/5 that we got in both cases here? Well, 3 4/5 is equal to 3 and how many tenths? It's 8. So yes, indeed, that's the same number. So you could have done it that way as well. So this, again, just like the previous example, if we wanted it to, we can use decimals to solve it. Okay? All right. So again, we have a way to double check it and confirm that we probably read the word problem correctly. All right? Sorry about that. My throat's giving out. Yeah. And by the way, this is not 25 plus 10 plus that 10. Okay. And just to do that on the side, just as an extra exercise, 25 plus 10 and 2/5 plus 10 and 4/5. Okay. We would still have the 6/5 over here, and we get 25, 30, we get 45 and 6/5 would be 46 and 1/5. Okay. That is not what they're asking you to do. We're just doing a sidebar quick calculation just to be more demonstrative of mixed number operations. Okay. Let's see, what else can we say about this? Um, oh, what happens is when I gave this multi-step thing here, let me change the color one more time so we can focus on the screen. Let me just use black. I originally said basically this was step 1 and this was step 2. And when you get this temporary answer, you still have to subtract this here. Some students forget that there's an extra part of the problem. They use this as the answer. Okay? In other words, that was this here, this 14 and 3/5. That is not the answer. Okay? The same kids over here, they get busy and they do this calculation right there and they get to 21 on the 5th and they say that's the answer. It's not. That's not the end of the problem. Right? So it's always worth, as an extra thing, at the end of solving your question, go back and give it there. Okay? And let's see what our hint is here. Pounds. So if you got something else that was not pounds, you're totally off base. The problem is the numbers I just circled, the X there, the 21.5, the 3 and 4, 5, they're all in pounds. So we kind of have to watch out with stuff like that, just to make sure we're kind of got a level playing field, if you will. All right. Yeah. Okay. This is a slightly involved one, kind of, sorta. So I'm gonna postpone this one. That's 48. I might spin this off into a second one. By the way, I do these. They're about an hour each. Sometimes 40 minutes. Sometimes an hour and 15 minutes. So they pivot back and forth. If something looks a little more interesting, I'll spin it out. For those of you catching on this in the replay, you can pause the question and then see how I solve it. And again, you guys should know by now that I'm solving this in multiple ways. This is a good time to mention that I'm Greg from GregsTutoringNYC .com, and you guys can email me at the bottom there, GregsTutoringNYC@gmail.com, about anything. Obviously, I'm a tutor. I'm more than happy to tutor you or your child, and we can work from there. If you have any questions, including follow-ups to some of these that I'm doing here, that's where we're going to be going into. All right. All right, so I kind of like these questions here where the bullets are there. It kind of lays things out. And sometimes you could just follow it step by step. Don't get too bogged down into that, though, because sometimes solving these questions linearly is not the way to do it. You need to get the full picture. I should state that, too, when I go through the questions. I've already read them. And it's easy for me to kind of get a solution in my head even before I'm halfway there. So it looks like I'm solving these linearly, but I'm not. I've encompassed the whole thing. I don't want to spend time reading the problem 3 times to you guys. So that's kind of the process there. Okay, anyway, by the way, so far on these questions, there's no illustrations. So then there's no geometry yet. So let's kind of see where this is going. They're sticking on fractions and multiplication and operations involving mixed numbers at this point. So let's kind of see where that's going. Jessie sets up a lemonade stand for 3 days. So that's probably important, right? We don't know. On Saturday, she sold 10 2/3 a gallon. On Sunday, she sold 3. You know what I'm going to do? I'm going to spin this one off too, because it's about algebra, and I'll put those together. Sorry, I just burped on top of this. Okay, 3 students performed a science experiment using salt in a beaker. The beaker contains 530.2 grams of salt before the experiment started. During the experiment, each of the 3 students removed 47.36 from the beaker. How much was left at the end? Okay, so again, we can do this a couple of ways. We can do 530.2 minus 47.36. Okay, get some number there. Let's call that x. Subtract, that was for the first student. Subtract 47.36 for the second student. Okay, get some value y there, and then subtract 47.36 for the third student here. And the final answer, we call that F a final, or just write final. Okay, and that will give us, we started out with that, that's that number there, right? And we took it off 1 time, 2 time, 3 time, right? So that should be what's left at the end of it, okay? One of the problems students have with solving this is if you do 530.2, they try to line up the numbers as if it was normal. So they do 47.36. Okay, the problem is this decimal point is here and this decimal point is here. You can't do that. You need to line them up. So you have to have 530.2, and then this dot has to be there. So the 3 goes under the 2, the 6 goes under nothing. Okay, the 7 goes under the 0, and the 4 goes under there. So what we have is these decimal points lining up. Then we can finally do the subtraction. And I'll do the first one there. So because there's nothing here, whether I'm going to put this double arrow, we can put a 0 there. So now we have the decimals lined up, and we have the tenths, hundredths, the fraction, the decimal areas lined up going this way from the decimal point onward, okay? So now we can do the subtraction properly. So what I'm going to do is do the computation to get x over here, because we're going to do the first number minus the first 47.36. So we can't take 6 from 0. We're going to borrow and make that 1. That becomes 10. That's 4. We have to borrow again, so this becomes 29. Okay, that becomes 29. We can borrow the 1 here. So we get 11, we get 8. The decimal drops down. Okay, we have 9 from 7 is 2. And now we have 4 from 2. We can't do it. We borrow 1 more time. That's 12. 8. So we get 482.84. By the way, we can double check some of these, because if you could do 482.84 plus the 47.36, we should get back the original number. So 6. So this is our check. So 4 plus 6 is 10, 0. Carry my 1. 8 plus 1 is 9. 10, 11, 12, 2. 2 dot 1. 3 plus 7 is 10, 0. 1. I get 9. I get 3. 1. And I get my 530.20. And we know we can throw the 0 off. So we get the 530.2. So I'll leave it to you guys to subtract the y, to subtract it the second time and then the third time. What I'll do is instead show you an alternate way. So let me change the color just so we know we're not going to mix and match these different ways of doing it. So since we know there were 3 students doing 47.36, we can also do 47.36 times 3. Okay, 6 times 3 is 18. Carry my 1. 3 times 3 is 9. Plus 1 is 10, 0. Carry my 1. 7 times 3 is 21. Plus 1 is 22. Carry my other 2. 4 times 3 is 12. 13, 14. And I had no decimal places here, and I moved over 1, 2 here. So I have to do the same thing, 1, 2 there. Okay? So let me just do that one more time to make sure I have it right. 47.36, that's correct, times 3. 6 times 3 is 18, carry the 1. 33901, 21, 22, 12, 13, 14. Okay, good. So now what I need to do is take the 530, because it's asking how much was left. Okay, the 530.2, and subtract from that the 142.08. Okay, so no matter how you slice this, this is a multi-step problem. The interesting thing is we had to do, this is number 1 here, and then this number 2 to get the answer here. Whereas here, I'm going to say part A, part B, okay, and part C. So it's pretty close. The number of calculations we kind of have to do to get the same number. So the final answer here is going to be the same as whatever the subtraction is here. We didn't do the subtraction. We only did it once here. We have to do it 2 more times. Okay, this is not the answer. 482 is not the answer. We have to subtract the 47.36 again and again 3 times. Over here, we multiplied it to figure out what they added up to be altogether, right? And by the way, this is obviously the same as 47.36 plus 47.36 plus 47.36, and add those up. Okay, we should still get the 142.08. All right, so what we're going to do is the same thing here. We're back over here. We need to put the 0 in here. Okay, 8 from that we can't do it, so we're going to borrow. That's 2. 1, we drop down our decimal, we need to borrow. That's 8, we need to borrow. That's 8, so we get 388.12. Okay. Okay. In the other example, I converted the fractions into decimals. We could have theoretically done that here. In other words, 47.36. That's the same as 47 and 36 over 100. Okay. The same thing here. That's 530.2. That's 530 and 2/10, or 20 hundredths. So we could have done stuff that way too. I don't know that that would help us. I personally prefer to work in decimals over fractions. But again, this deals with fractions. It deals with mixed numbers. The mixed number in this case being the decimal, like 47 and 36 over 100. Okay, and the operation. So this operation, again, that didn't involve any multiplication, but it involved the distance subtraction no matter which way we did it, whether we did it the black way or the red way. Okay. And it required us to really understand what the word problem was asking of us. All right. So again, we have a multi-level problem, if you will. Okay. And this check I did here, this should be a running theme you guys have. We could also take this here, this line here, and this line here, and add them back up to make sure that it's actually the 530.2 or whatever. Okay. Okay, and I think I don't know if there's anything else I can say about this. The only last thing I want to say is it was not the 530 plus the 47. That would give us like, this is about 50. That would give us about 580. That's not the solution here. This is how much was left. Okay, which normally implies subtraction. Sometimes they may give us a subtraction using the word difference. That was not the case here. But they could have said what was the difference between the original amount in the beaker versus how much was left. Okay, but we're not looking for the difference here. We're looking for actually the total quantity of salt left in the beaker, or wherever it came from. Yeah, using salt in a beaker. Okay, 51. Let's give this one a shot. So Mrs. Ty's living room was, so it's, normally we might think of it like it was a blueprint, like 10 by 5 or something, which means the area would be 50. If this was feet and that was feet, this would be square feet. Okay, but they're bringing the whole room as a three-dimensional thing. Okay, so the dimensions of the living room are this. They are now currently these three numbers here in the red. And the dimensions of his family room, a second different room, is 14 by 20 by 8. What is the total volume of the two rooms? Okay, so basically we need to do 10 times 18 times 8. Okay, and that's the living room. Okay, and we have to compute that. And then we have to do the same thing for the family room. Okay, and that is 14 by 20 by 8. Okay, compute that. And then it says what is the total. So the total is equal to the living room plus the family room. Okay, so this just becomes a nasty multiplication at this point. Okay, we can split this up into many different ways. Let's just take these for what they are at the moment. There's many ways to do this. 10 times 18, right, gives me 180. Okay, I have to multiply that by 8 now still. 8 times that is 0, 4, 6. 1440, I believe, is the answer. And I'm going to compute this a different way in a second to confirm that. And then we have 14 times 20. So that's 280. Okay, and that's going to be multiplied by 8. 0, 64, 6, 16. That should be 2040, I believe. Okay, and let me just do these different ways to make sure I'm understanding this. I'm going to change the color of the pen for a second. Let's use purple. 18 is the same as 9 times 2. Okay, so I can basically replace it by that. So 9 times 8 is 72. Okay, so I've done that, I've done that. Okay, 72 times 2 is 144. And now all we have to do is multiply it by 10. So yeah, I got that. Okay, so I'm going to try the same thing here. This is the same as 2 times 7. Okay, I'm going to do the same thing. 7 times 8 is 56. Okay, so I did that and I did that. I'm going to multiply it by 2, so I get 112. Okay, okay, so that's the 2 there. And now I have to multiply by 20. So I'm going to get 224 with the 0. So this calculation I did a second ago was wrong. So let me go back to that. 14 times 20, 8, 2, 8 times 0 is 0, 64 is 6, 8 is 16. Yep, that should have been 22 right there. Okay, so I have a way to double check this. Okay, so this should be 2240. And then at that point, we have to take the living room, 1440, plus the 2240. Get 0, 8, 6, 3. 3680 should be our answer. By the way, some kids get as far as getting the 1440 and they stop. Okay, some kids get as far as doing the 2 of these and then they make 2240 the answer. Okay, you gotta piecemeal these things and figure them out properly. Okay, and by the way, our answer is in feet cubed or cubic feet. Okay, and we should be able to get that hint from the answer. Yep, cubic feet. Okay, so we can always use this little thing as our guide just to make sure we're kind of on ballpark here. All right. By the way, we could have estimated some of this just to give us a ballpark as well. This was as if it was 10 by 20 by 10, right? What does that give us? Right? That gives us about 2,000. Okay, you might argue 2,000 is a lot higher than 1440. It's an estimate. That's what estimates do. And this one was basically 20 by 10. And then the 14 is in the middle. It's almost 15. So we could have done 10 here and get 2,000 again. Okay, or we could have brought it up to 20 and got 4,000. So we end up getting a number that's 5,000 or 6,000. But that's still relative. You have to compare it into the relative kind of closeness to it or not. All right? All right, so that's that there. So this is really a multiplication problem. It's also testing, do you know what volume is? Okay, and they kind of even give it to us by showing us this x here and this x here, showing us this multiplication. Okay, so this is really about a word problem, kind of a tiny one. It was multiple steps. You had to know to do that. It's about ripping it apart again, doing an analysis properly. It's about you double checking. I used the red to do the main computations, and I double checked it a different way. By the way, even a good double check sometimes is just to flip the numbers, do 18 times 10 instead, or do 20 times 14 instead. I personally like to use the zero numbers at the bottom, but it works just as well with the zero numbers on top. Okay? We could have also done it in a different order. I did 10 times 18 times 8. I could have done 18 times 8. Okay? And then multiplied that by 10, whatever that answer was. Kind of doesn't matter. As long as you do them properly and you're taking it a step at a time. You don't want to be zooming through these questions all the time. Sometimes you guys are in predicaments where you're being asked to answer something fairly quickly, but so be it. And just the last thing, this was T equals L plus F. We were not going to do 2240 minus 1440. Okay, that's not what they're asking you to do here. It was what is the total volume? That means addition. Okay, I'll normally use addition. It could also mean we were supposed to multiply something together between the living room and the family room. So that's not really where they're going there. All right. All right, let's try the next one. Okay, I'm going to skip this one. I'm going to spin that off with the second one, or maybe even do a third one. Okay, this one I'm also going to skip. So we have a second video coming along. Oh yeah, oh yeah, oh yeah. Let's see, what about this one? For 4 weeks in June, Cameron biked 3 3/4 miles each week and swam 2.5. For 3 weeks in July, he biked this and swam that. How much greater distance did he bike in July compared to June? Okay, so there's a couple of ways to do this again. There always is a couple of ways. And by couple, sometimes I mean two, and sometimes I mean a bunch. Okay, if you notice as we solve each one of these, we're going off into different kind of aspects of it. So one thing to do is to keep June by itself. So June, he does 3 1/4 mile biking plus swimming. So that's 2.5. Okay, so if we add those together, we have to get a common denominator. So we're going to get 3 1/4 plus 2 2/4, right? Because a half is the same as 2/4. And we get 5 3/4. Okay? That's the June. Okay, it tells us for 4 weeks he did that. So what we want to do is multiply this by 4 now. Okay, there's 2 ways to do that. One way is to multiply the 5 times the 4 and get 20, and then multiply the 4 times that and get 12 fourths. Okay, so 12 fourths is the same as 3, so that equals 20 plus 3, or 23. Okay, the other way to have done this was to map this into a top-heavy fraction. And we get 5 times 4 is 20. We get 23 over 4 times 4 over that. Now we could multiply out the numerators, or we could just cancel these. If you notice, we still get 23. So 23 what? 23 miles. It's good to keep track of your units all the time, okay? In July, if we do this the same way, he bikes 4 3/4, and he swims, that's a bad B, he swims 3 1/2. So we do the same thing. We're going to do that conversion to get the common denominator. We have 4 3/4 plus 3 2/4, right? 1/2 is the same as 2/4. And we get 7 5/4. Okay, 7 5/4 is the same as, because 5/4 is the same as 1 1/4, we get 8 1/4. Okay, he does that for 3 weeks. So now we're going to multiply this by 3. We can do it both the same way again. 8 times 3 is 24. Let's do this to make sure the numbers are not going to get bumped into each other. 8 times 3 is 24. And then 1/4 times 3 is 3/4. And that's it. We're done. We could also map this into a top-heavy fraction. 8 times 4 is 32. We get 33. Over 4 times 3. That gives us 99 over 4. Okay, and that equals, if we map that back into a mixed fraction, 4 goes into 9, right? We can do that over here. 4 goes into here twice. We get 8 with 1 left over, right? 4 times 4 is 16. And then we have 3 left over. So in both cases, we get 24 3/4. Okay, so some students stop when they get to 23 over here and think that's the answer. It's not. And some students stop when they get to 24 3/4 and think that's the answer. It's not. So let's reread the whole question and see where we're at. For 4 weeks, and if we make this sentence A, if you will, for 4 weeks he biked the 3 3/4 and swam whatever. That's this. This is A right there. Okay, and then for 3 weeks he did that. This is, if we make this B. Okay, this is our B here. Okay, if you notice, this still is here. How much greater was the distance he swam in July compared to what he did in there? Well, it's going to be the 24 3/4 minus the 23, which is 1 3/4. 1 3/4 what? Miles. Okay, let's see if our unit in the answer gives us that. Yep. You notice they got cued here because if the answer was 1 mile, then there was no S. So we don't know. They gave us a little bone, but not enough bone to work with here. But at least they threw us a bone. So there's that. We get 1 3/4 miles as the answer. Again, we could have solved this with decimals. Let me change the color of this just to explore that. I'll use my handy dandy red. So 3 1/4 is the same as 3.25. Okay, 2 1/2 is the same as 2.5. We could have added those up. We can get 5.75. Okay, we're going to multiply that by 4 and get whatever answer we have there. We're going to do the same thing with with this here. This is 4 7/5. This is 3.5. If we add those up, whatever that is, multiply that by 3, and then add whatever this was to whatever that is, it'll give us the same answer, which we know, because we know the answer is this, would eventually give us 1.75. So why don't you guys do that on your own? And if you don't get the right answer, you can email me. And if you get the right answer, you can leave a message in the comments. And not enough of you guys leave comments here. It's a good time to mention, please subscribe to the channel. Please like the video. Okay, there's more coming. Tons more coming. There's still another way to do this. Which is that if we take, let's use dark green here. If we only work from the biking first. So he bikes 3 1/4 times 4 in June plus 4 3/4 times 3 in June. And then he swims 2 1/2 in each of the 4 weeks in June, plus 3 1/2 for the 3 weeks in July. Okay, and if we add that up, that's whatever that is, we get a double here. Okay, so then we're going to be comparing these two and subtracting those two. Again, that's, you guys can do that offline and see if you still get the 1 3/4 back or the 1.75 right there. They're both, these are all legit ways to do it. The red way, the purple way, the green way. They're all different ways to view the problem. And often you should be using 2 different ways to double check your answer. There's lots of computations going on there. It's so easy to make an error. And this is a good point to also point out that the complexity of a question is often at hand, and a lot of kids lose points because of that. They can't map the math to the English or the English to the math or things like that. They can't understand a word problem. There's also students who do that and lose full points because at the very end they make some sort of what's categorized as a silly error. And it really almost never is. How could you lose full points if you solve the problem correctly? It's your attention to detail. You're not looking at something specific. And you make one last slip up at the very end, and you've lost it all. Okay. The thing with the show you work section is at least you get partial credit. But if this is on the multiple choice, then you're up the creek. And it's something as simple as me saying, if you did the first part and got this 23 here, you did a lot of math at that point. You figured it out. You knew what was going on. But somehow you didn't realize that was not the end of the problem. So a lot of students lose points where the thing isn't really a math concern. It's doing it. On the same hand, this is about your math proficiency. It is reading questions correctly and processing them, going through the process. The word process is important in a lot of this. All right, so there's things like that as well on top of all this. Okay, all right, so we have, this is testing mixed fractions. It's testing our attention to detail. It's testing multiplication of fractions, including converting them to decimals and or top-heavy fractions. By top-heavy, I mean like how I converted this 25 3/4 to 23/4 over here. Things like that. And again, it's just testing your normal multiplication skills and stuff like that, because we still had stuff like 8 1/4 times 3. You still need to know how to do that. Okay, the 33 times 3 over here become easy, but 8 times 3, some of you still don't know. That's 24. And that's going to just torture you guys for the rest of grade 5, the rest of grade 6, the grade through high school, into college. This is something you need to figure out. It's worth spending the time now to get that worked out in your head about what something may or may not be. Okay? And this is the last question. Again, we skipped some. Let's see, how we doing on time here? We're 55 minutes. So what I'm going to do is I'm going to end this and split the other parts up into other pieces. All right, guys, have a nice day. Chill out.